ஸ்ட்ரீமிங் ஆரம்பிச்சு.
இல்லை சார், அதில் பிடிஎஃப் இல்லை சார், எல்லா லேப்டாப்பும் அது அங்கே போயிடுச்சு. லைவ் போகுது சார், இதில் ஒன்று வச்சிட்டோம், அங்கே ஒன்று வச்சிட்டோம். சார் லேப்டாப் நேற்று போச்சு சார். அது பிபிடி இருக்குது சார், மேப்பில் வந்து பிடிஎஃப் இருக்கும். அப்படியா பிடிஎஃப் சார்? நான் ஒரு செஷன் கூட அட்டன் பண்ணல சார். இதுதான் பார்த்துட்டு இன்ஸ்டால் ஆகுது சார், பிடிஎஃப் இன்ஸ்டால் ஆகுது, லைவ் ஆகிடுச்சு.
லைவ் ஸ்டார்ட் ஆயிடுச்சா
சார்? லைவ்
ஸ்டார்ட் ஆயிடுச்சா?
ஆமாம் சார், லைவ் போயிட்டு சார். பிடிஎஃப் டவுன்லோட் லைவ் போயிட்டு சார்.
ஜான் சார்
சார் இல்லை சார், சார் அவர் பண்ணுறேன் சார். ஆமாம் சார்,
டூப்ளிகேட் பண்ணி கொண்டு வேண்டியது, இதை டூப்ளிகேட் பண்ணிட்டு பண்ண வேண்டியது.
அதே ஸ்டாப் பண்ண வேண்டியது, அதான் தெரியல. ஸ்டாப் பண்ணிட்டு லிங்க் மாறும், திரும்ப லிங்க்
மாற்றிட்டு வளர விட்டுலாமா இல்லை இருக்கட்டும் சார் இந்த லைன் ஓட்டிருக்கோம் சார் சார் எதுவும் வேண்டாம் சார் அப்படியே போட்டோம் ஒன்றும் பிரச்சனை ஸ்டார்ட் பண்ணிக்கலாம் சார் இருக்கட்டும் சார்
நேற்று இங்கே ஒன்றுதுலேருந்து அது நேற்று சிஸ்டம் எங்கே
சார் டவுன்லோட் ஆயிடுச்சு சார் அவ்வளோ ஒன்று சார் வந்துடுச்சு சார் அது இன்ஸ்டால் ஆகிடுச்சு அப்ரூவ் பண்ணிருக்கலாம் அப்ரூவ் பண்ணிருக்கலாம்
கான்ஃபரன்ஸ் எங்களுக்கு மட்டும் ட்ரைனிங் உங்களுக்கும் ட்ரைனிங் தெரியுதா எப்படி ட்ரைனிங் கொடுக்கணும் பார்த்தீங்களா
So very good. respected, colleagues and dear students. First, I would like to, convey my regards and thanks to organizers who invite me for this talk and giving me the opportunity to deliver the talk in front of you. So first of all, I'll be just telling you, some of the things ma'am has already told you. But I did my MSc and BSc. That is not mentioned in my resume. Of course, it is there, but that's not that important. But why I want to tell you about this? I did my BSc and MSc from a government college, Alwar, Rajasthan, which is a very very small college right now also. And like you people, the way you people are doing. After that, I wrote my GATE examination and I joined IIT Delhi. So when I joined IIT Delhi, I was interested to do my PhD in complex analysis. That's what I knew actually before entering into the PhD. But then I remember that Professor J.B. Srivastava, he was head at that time, and he told that no, complex analysis, no PhD in complex analysis. Like that he reacted. He said that nobody is available in complex analysis in IIT Delhi. Think about something else if you want to take an admission over here. After the interview, he talked to me like this. We were just having a personal interview. He asked me that, okay, what was your rank and all. So I told him that, okay, I'm getting 84.3 percentage in my MSc, and since I was in a college and the university topper, the Rajasthan university topper, was 1 mark ahead of me, just 1 mark, gold medalist. She was gold medalist and just 1 mark ahead of me. I thought that okay, I'll get the second position then. So then I got this information through the Rajasthan University people, the administration, that no, since you are doing from a college which is affiliated to Rajasthan University, we cannot give you the second rank. Second rank will be from the university student only. I said, okay, fine. I was very, very introvert person. So I thought, okay, leave it and think of something more, think something else also. So I wrote GATE exam and entered there. And then Professor J.B. Srivastava, he was talking to me like, no complex analysis, think something else then. I said, okay, fine. And okay, then you suggest me like that. I was looking at his face, Professor Srivastava. And then he took me to Professor Suresh Chandra's office. And Professor Suresh Chandra was like, no, I'm going to retire. I will not take any PhD scholar now. So he was working in convex optimization. And then after a few discussion, he asked a lot of questions to me. And then it's like, okay, fine, I'll take her, but with a joint PhD. So my co-supervisor was, I should say he is, Professor Vagish Shukla. He works in category theory. So I started my PhD, term working in category theory, and after a few months I realized that no, it's not for me. So then I came back to Professor Suresh and told him that no, I am not able to get it completely. I should have something else. So then we started working in fuzzy matrix and biometrics games. So I can say that my PhD is basically kind of combination of optimization as well as soft computing. So fuzzy matrix and biometrics games, that was the my thesis title. And after that, after my PhD, I joined Amrita Vishvidyapeetham, the School of Engineering, Bangalore. So 1 year I worked over there, and I really enjoyed that period of my teaching till now. If somebody will ask me that I am in Central University more than 10 years. But if somebody will ask me that what is the best teaching period, then definitely I will say that Amrita's period. Yes, that was wonderful period. I remember that there were 158 faculty in Amrita, and when I was about to leave them because I had to go to US for my postdoc. So I still remember the principal told me, Professor Nagaraju, he told me that you can go on without pay leave. We want that you should come back and join us. I said, why, sir? Then he showed me that, you got 4th ranking out of 158 faculty. And I think this is because of the students also. Because those students are so much focused, so much clear, and they were so much attentive. So I really enjoyed that period of my teaching. And after that, I joined, of course, Professor Lotfi Askarzadeh, and 3 years I was with him in UC Berkeley. Wonderful period, that is also there. I will tell you why it was so wonderful later on. But then when I came back, I joined Central University as in mathematics department, and recently I joined Department of Data Science and Analytics, and I'm heading that department. Now why I'm telling this story to you people? because you people are in BSc and MSc stage, right? So you can think of, if you're doing BSc in mathematics, MSc in mathematics, or BSc in computer science, or computer application, or MSc in computer application, think about something which is interdisciplinary. It's not needed that if you are in mathematics department, you are restricted to be in mathematics department. You can always move to some other relevant department, right? And of course, data science and analytics, this is very recently, upcoming area, and I believe that next 10 years it will be on the boom. That's for sure. After that also, but yeah, in future there could be a quantum computing and blockchain. These two things will be upcoming areas. After 5 years, people will be preferring to moving into that direction also. So the important part of my this whole journey is I started from zero. Nothing was there. In my college, no teacher was available. I was sitting in the library, that means on the ground, and studying. So much dust, and no teacher was there. Government college in Rajasthan, that means nothing is available. So you are, I always say this thing to my student also in Central University. When they complain something, I say that complaining is, very easy. But if you're getting a teacher, somebody is coming to your class and teaching you, good enough. Try to learn from there. So, and above that, after my, post-graduation, I got Professor Suresh Chandra, Professor Vagish Shukla, my mentors. Then, of course, Professor Lotfi Askar-Zade. Then I met Professor Ashok Deshpande from College of Engineering, Pune. I was working with him during my postdoc. Then, of course, Professor S. Dharmraja. Some of you might have listened him yesterday. So you can make out all these mentors of mine. They're so humble. Of course, they're very strict. As Professor Dharmraja told that 8 o'clock class, if you are late by 8 o'clock, then you will not be entering. I'm the same kind of person. But then at the same time, all of these are so humble, so down to earth, you will not feel that, oh, what is the gasture of that? I'm talking about my postdoc supervisor. He is like founder of Fuzzy Logic, and everybody knows about him. But whenever I asked him, how are you, sir? Then he's like, he's so far, so good. That's sir. So he was again so much humble, down to earth person. I never realized that I'm working with such a great personality. So with that, I just motivate you people. You can try your best and think high. Just think about research, and of course that is very much needed. And when the NEP will be there, I hope that NEPs you people are bound to follow, right? Some of the things. Okay, so yes, of course, once the national education policy is, there, then definitely you have to think about interdisciplinary work. People have to think, just the pure mathematics, if you are working in algebra only, that's not working out after 10 or 15 years. You have to think about, okay, I'm working in algebra, then I should have a knowledge of the cryptography also. I should think about some application in cryptography also. And the same with any other area of mathematics, and of course with the computer science also. So there has to be a merging between the different subjects. When I teach in my class, if I'm teaching probability and statistics, I always tell them that think about how you can relate the probability and statistics with optimization. How you can relate this optimization with linear algebra. So the student should have this kind of interconnection. Should have the thought about interconnection between two different subjects. And any other subject, whatever you people are studying, then they look at me and they feel that how it is possible. I'm reading algebra, but algebra only, how it is related. So one has to tell them the application. While teaching also, it's very important that, if I'm talking about the linear regression model with him, then definitely first I teach them linear programming. I actually tell them that how, linear function, starting from the linear algebra, then I come to this linear regression model, and then I explain everything to them. So the same with you people, whatever you study, any subject in which you are getting the, interest, try to connect that particular subject to another subjects also, and this will enhance your research pointer, or of course how you can apply that particular area. That's again very important. So with this, short thing, I'll come to this the title, if you are seeing, of my presentations. I think the presentation title which I have given you people, that was slightly different, but more or less the same only. So semi-macro modeling for power efficiency of NB-IoT devices in 5G networks. So see, the title has 3-4 things. First, I'll start from the last word, that is what is 5G networks. Everybody knows about it, what is 5G networks, which people are using now. Then the other one was NB-IoT devices, the word which I have used there. And then of course power efficiency, that's very, very important. And then we come to the semi-macro modeling. So this semi-macro modeling, I'm not coming to that point now with you people, but yes, of course, all these 3 points we can discuss over here. Before that, I can talk about what is a cellular or mobile network. So how you understand the mobile network? Can somebody say about it? So mobile network, everybody knows about it very well. But I'm just explaining over here that basically wirelessly you are connecting the mobile devices, isn't it? Earlier we were having, I mean, I don't know, at your time it was there or not, but with the cord, with the wire we were having the phone, we were using. When I was, BSc, MSc days, I was using the phone which was having the wire. We were not having the mobile phones that time. So, but in your case, yes, of course, you can think about the cellular network or the mobile network where everything, I mean, the mobiles are wirelessly connected and it's so easy to talk. Next slide. Yeah, next. Okay, so here it is shown. I'll be actually telling you what type of my research area rather than going into the depth of the mathematics, just showing you the area, the research area. So you can think that, okay, mathematician, where we can work, in what type of areas we can work. So here if you see this picture, cellular A. So basically what I'm saying this person is making a call. Then this is mobile tower. It goes to mobile MTSO and then again the mobile tower and the cellular B. So the call is actually started from A and then it is reaching to B. Right? So how it is like this? See the mobile tower, if you see, you can point it. So mobile tower is nothing but the way you understand mobile tower, but actually in technical terminology we use the base station, terrestrial base station. So once the call is made, the radio signal through the different fixed antennas, it will be transmitted and received by the cellular B, received by the person, another person. So these are the things which is very important to understand, but yes, of course, as a layman, we don't even go into the depth of that. Next slide, please. So now, if anyone of you attended yesterday's Professor Dhanraja's lecture, he mentioned one of the things that the area, the cell area, if you just see over here, this is a hexagonal one. So anyone has attended yesterday's lecture? Just one point, one terminology he used, cell area. So he mentioned this, that okay, this has to be hexagonal, not a circle. Just think about, if it is a circle, then definitely if you join 3 circles, there will be a portion left out, which we don't want. We want that each and every portion of the earth should be well connected through the tower. So this cell will be actually of hexagonal shape and each cell will be having one tower. Okay, so one tower in the sense, like I'm talking about one terrestrial base station. Now in this picture there are 3, one thing is I just explained. Another thing is, if you talk about village, okay, sometimes getting connectivity in the village will be slightly difficult because of the reason is that base station are quite far away. While if we talk about the urban area, it will be very dense, and then dense urban area, oh, you will not find any difficulty to get the call connected. It will be so easy over there, and that's the reason, because we are having more base station, more fixed antennas available over there. Okay, next slide. Okay. Just a minute. So, okay, next slide, and then we'll come to this slide. Okay, so here if you see, again I have shown you base station A, base station B. So once we talk about the base station, which you understand as a mobile tower, here what is happening, there are actually 2 types of calls. So it's a very basic information I'm providing you to think about. Okay, not just computer science, electrical engineer people are working in this area. Even the mathematician, they're also working in such type of areas. So here there are two different type of calls. One is that new call and another one is hand of call. Now what is a new call? I just explained you about the cell. So let's assume that we are sitting in this room and we are making a call. Okay, so my call will be connected through the tower which is actually in this area, right? Once it is connected, then it's fine. It's called. It will be as a new call. It will be considered for that particular situation, for that particular base station. But let's assume that I'm here. I'm making a call, and I'm taking a taxi, and I'm moving away from this place. So once I move away from this place, then actually what is happening? My call is connected to this particular cell tower. But once I make a move and I'm going away from this cell, my call will be actually shifted to another base station which will be the nearby one. Okay, so like that my call will be shifted to one to another to third base station or something like that. That will be considered as a handoff call. Yeah, go to the previous slide please. So this is a very basic information which I am providing you. Call means this call can be of either type. This could be a video call, this could be a data call, this could be a voice call. Of course, voice call is very, very important because that's a real time, and of course the video call also. While the data call cannot have the real time scenario, it can have some delay also, that's alright. But voice call, definitely there should not be any delay. If there is a delay, I'm not able to talk to you then. So there are two very important performance measures in case of the wireless networks or the cellular networks. These two performance measures, that means we are actually finding out the quality of service of that particular system. So one is called the call blocking, another one is the call dropping. Now what we meant by the call blocking, when I make a new call or when I make a call, my call is not connected. The reason could be the tower does not have any channel available, does not have any frequency available. Let me make you very clear in that way. If the base station is not having any available frequency or the channel with it, then definitely my call will not be connected. So that will be called as a call blocking. Another one is, let's say I make a call over here and I'm making a move and I'm going to the adjacent place or airport or somewhere. So then my call will be actually moving from this base station to another one. Now it will be if it in the next base station, the targeted base station, if there is any frequency available or the channel available, then the call will be transferred and definitely there will not be any issue. If this is not the case, then definitely my call will be dropped. So call dropping, the people who are using 3G, they know very well that the call dropping was a big issue that time, big issue. So that was sorted out with, of course, 4G, and now of course there is nothing like that. But yes, of course, these two performance measures are very important one, and still people who are working in this area, they are actually working in this way also. Yeah. Next slide. Yeah, next. Okay, so this is the slide which is actually showing you the evolution from 1G to 5G. Not even 5G, actually we can think about 6G also. People started working in 6G right now. So let's have a look over here. Each and every type of network, right? We talk about the 1G, 2G, 3G, 4G, 5G or XG or 6G, whatever. Each and every having a different type of features, special characteristics and capabilities and features with each and every network. I'll not go beyond the 3G. Let's start with the 3G because some of us have used 3G actually. So you can think about, yes, there was video, live TV, buffering was there definitely. There was a slow transmission, but still we were able to get it. Now in case of the 4G, yeah, there was not at all as such any difficulty. There was not as such any difficulty with the 4G, and it started in 2010. We were having the video streaming quite good. But nowadays, whoever is using 5G, anybody can give me an idea of how, like when the 5G network started, inaugurated in India? Any idea about it? Yeah, October 22, right? Prime Minister inaugurated that one, right? So 5G networks, there was a lot of people who were working in 5G networks. I think almost 40 researchers from IITs. There was a big project. So we were like we will not say that among of those 41s or those people, but yes, there was a chain, and me and Professor Dharmaraja. Professor Dharmaraja was one of them, and I was working with him in 5G networks. So there we started actually working it out. So 5G networks, what are the special characteristics? I'll be talking about that. But definitely, if you see over here, I have written some of the points. 100 times speed of 4G, which you can realize very easily, right? Another one which I have mentioned, the download speed. Yes, of course, the download is too fast. You just click over the video and you will be watching it. And the same with the upload also. The upload is very quick now. IoT. Anybody can explain what is IoT?
Internet of Things, connected devices. We have
Sit down, sit down. Come on.
we'll have thermostats and television will be smart TVs. Internet of Things.
Okay, so when you talk about Internet of Things, can you explain that? What type of devices you can put under IoT?
Fans, lights.
Yeah, whatever which does not need a human intervention, and it can work itself, that we can consider as IoT. Even the smartphones also can I consider as IoT device? Yes, right? Because there are so many applications which you can do without your interventions, right? Okay, so smart cities. Ajmer is again declared to be in future smart city. But what do you mean by the smart city over here? So when you use the ICT, all the computer technologies and all, and you make the in such a way that of course the government will be having the much more benefit from there, and all the administration and the work will be in a better way. So this is how the smart city, some of the smart cities are already declared, but of course there's a very few work is done in India till now. Autonomous car, you have an idea about the autonomous car, right? In right, yes. So there, of course, 5G networks is very important, because quickly everything has to be done. The network has to be wonderfully placed in case of such things. And then the last, I have just two actually applications I'm putting, but this IoT word itself is huge. People are just doing the research in IoT device. That's all. So many people are working in this area. Similarly, if I'm talking about the remote robotics or the remote surgery, something like that, in China, people are using the robots for the surgery, especially some knee pain or some knee replacement or something like that in China. I think long back they have done 1 year back itself. So all these things can be done once the network is wonderfully placed. And further on, I'm not talking about, yes, of course, 6G. It is having its different type of issues, but yeah, of course, 6G right now we are not having in India at all. And let's talk about the 5G networks. Please go to the next slide. Okay, so these are the main some of the characteristics which I have explained as such, but these are the main characteristics of 5G networks, which you already know somewhat. You have, experienced it. So that's why I have taken this slide over here. The very first one is enhanced mobile broadband. So when you talk about the enhanced mobile broadband, it's a very, kind of technical term, but then you have already experienced. How you have experienced the faster data transfer rate, right? That is nothing but enhanced broadband, mobile broadband. So next is ultra reliable and low latency communication. That also you have experienced. Ultra reliable, of course, when you send a message, you know that it will be reached, right? So kind of in that way you can understand about the reliability. Another one is low latency communication. Of course, in 4G network, it is much lower latency. What is the latency? That is nothing but delay only, right? As I said you earlier also, when you communicate with someone, whether it's through the WhatsApp or the text or anything, if you are in the 5G network, your message will be quickly delivered. And it will be like, you are just talking one-to-one. So that's called low latency communication. Another one is massive machine type communication. So of course you can connect a lot of machines once you are in 5G networks. So these three are very important characteristics of 5G networks. Let's go further. Yeah, further. Next. Okay, next. I don't want to talk about such things. I already told. Yeah, next. Okay, so once we are in 5G networks, there are a few important power saving mechanisms already declared. This one is declared sometimes in 2009, and if somebody is interested to read more about it, he can refer 3GPP site, that is third generation partnership project. Once you write that third generation partnership project into Google or in the ChatGPT, you'll get all the information there itself, and you can think about, okay, what type of new technologies are available in 5G and 6G networks. So I think release 14 to release 17, lot of informations are already available. I'm just talking about three informations over here, or you can say three power efficiency mechanisms. But before that, I'll ask you one question: why do I need a power efficiency mechanism in case of the 5G networks? Can you think logically and answer this? Just, you don't need to have any knowledge, just think about with your experience. Can you think about why do we need such type of power efficiency mechanism in 5G network? Why we are talking about this?
If you are trying to achieve 100 times the speed of 4G, then 100 times more frequency will be transmitted and received.
Right, so go ahead. And then
In order to transmit such high frequencies, we will require more power.
we, in the sense, the user equipment which you can consider as the mobile device, right? So no, right, so you are completely correct.
So we have to
Yes.
optimize
The power efficiency, or you can say that the battery efficiency of the mobile device. If you just keep it aside, you'll feel that, oh, okay, after some certain time it is drained out, right? Isn't it? In case of the 4G, some of the phones, right, it was happening that you just keep aside and oh, I didn't use the phone, still my the battery of my cell is gone, right? It was happening earlier. But nowadays, when you talk about the 5G mobile devices who are supporting the 5G, they are having such power efficiency mechanism within it. Like for example, right now, if I'm keeping my phone aside in the night, even if it is on the network, it will not giving me any noise, any interruption. I will not receive any, this phone will not receive any data, any the voice call is coming, that definitely it will be there, but the messages will not be there. But the moment I just pick it up and I switch it on, then one by one I'll be getting the messages. If somebody has noticed that, so then you can realize this point. So this is nothing but power efficiency mechanism is on for that particular mobile device. Let's talk about that. So here, if you just, here I need that. This one? Okay. Where? Towards laptop, ma'am. Towards laptop. Towards laptop. Towards the laptop. Pointer, ma'am. Short, okay. Laser. ಅದು laser கொடுக்கல, அந்த பொண்ணு remote தான் வந்துச்சு.
Sir, remote
This one? Yeah, I was pressing this one. Okay, it was up there. Okay. So this one, if you just see this, there is a circle, that's a blue circle, and then there is a red circle, then there is a blue arrow. Let's talk about this. So this blue arrow, let's right now the work which we are doing, earlier whatever the research I have done, I have considered the calls as so the call was, I have considered as new call, handoff call, like that, and I made the research papers over that. But this work is in 5G networks. Rather than we are talking about the calls either as new call or the voice or the video call, we are considering the packets, because each call, whether it's a voice call or a video or a data call, it will be coming through a small package, one by one. Once a call is there, that means we are talking about a number of packets for that. So this is how one call is completed, whether it's a text message or a voice or a video one. So here I'm talking about the packets only. So this blue arrow shows that one packet arrives. This is a DRX mechanism, which is nothing but discontinuous reception mechanism. The discontinuous word, everybody knows about it. Something is broken, right? That is the discontinuity. So here, this blue arrow shows that the packet arrives. Then, if you just notice that the blue circle, it's like start inactivity timer. So for example, rather than this, I'll just take a classroom example or my office example. Let's say I'm sitting in my office, I'm the mobile phone basically, and I'm sitting in my office, and when a student comes, right, I attend that student. When he goes, I feel that okay, I can relax. My inactivity timer starts. The moment it starts, another student comes. So you see that another blue arrow is there, right? So once I attend another second student, then again after once I attend it and he goes, then my inactivity timer, or I can say that the inactivity timer resets, right? That's how the inactivity timer again starts. So then I realized that after a certain time, another student comes. Okay, then again after, once I attend and he goes, my inactivity timer resets. But then since long, like this inactivity timer, I think that okay, my 5 minutes will be my idle time. I'll be just relaxing. Feel like if nobody will come, then I might sleep. You cannot go to the sleep just like that, right? You need a 5 minutes the time so that you'll go for the sleep. So let's assume like that okay, once I attend the student and he goes off, my inactivity timer resets, and then after a certain time, like let's say 5 millisecond or something I have set in the mobile phone I'm talking about, then there is no call packet comes, there is no student is coming, then definitely I'll go on sleep. Right, so then my mobile phone will go for a sleep period, and that will be a fixed period. So if you just notice over here, S1 is my inactivity timer. S1 is the inactivity timer for the mobile phone, and it will be a fixed period. Once the call packet is coming, fine, it will be attended. But after a certain time, when there is no call packet is coming, then definitely the inactivity timer will be reset. And once it is completed, the mobile phone, I will just open my eyes and say that, oh, okay, at the door, is there any student? No, there is no student. Okay, I'll be going on sleep then. Like that. Though it does not happen in the office, but I'm just taking an example. So then S2 is what? S2 is basically, mobile phone is just opening the eyes. It is checking. There is another terminologies over here, but there is just a checkpoint whether the call packet is there or not. Once the call packet is not there, then there's S3 period, which is called the sleep period for the mobile phone. It will start and mobile phone will be sleeping. Once it is in the sleep mode, then definitely the power will be saved. So this is how actually in DRX mechanism our mobile phone power is saved through this one. So it's a very important, it's a legend mechanism basically, I can say. So this is how 5G mobile phones are working, and this is the very first one which is introduced. So here I have shown short sleep. I don't know whether it's visible or not because the font size is pretty small. So short sleep, again I have written short sleep. It will be depending on your mobile phone, how many times you are putting, how it is, architecture has made this particular mobile phone. So there could be more than one sleep state. There could be just one, there could be two sleep state, like that. So once there are some short sleeps, then it will go automatically in the long sleep if till now there is no packet arrival happens. So there is a long sleep then. Once the timer of the long sleep is done, then again it will be in the inactive mode and it will be checking out for the call packets. So this is how this whole DRX mechanism work. Next slide please. Okay, so this is called extended discontinuous EDRX mechanism, and the other one is a power saving mechanism. There's a lot of theory behind it which I'm not introducing over here. So EDRX you can consider as extended one. Whatever the DRX mechanism is doing, the period is basically enhanced over here with a slight different scenario. Okay, next slide please. Okay, next slide. Okay, so this is the last mechanism for the 5G networks which I'm talking about. This can be understood in a very simple way. Okay, you use torch, right? And I'm using this pointer. So when I'm using the pointer, or I can say laser light, right? So just one beam is there in the laser, while when I'm using the torch, there's a lot of light is there. So this is something like that. So here GNP is nothing but base station. As we started mobile tower, then we use the word base station. GNP is again that one only, but slightly different because we are talking in 5G networks. That's again a different story about it. You can read through the chat GPT, you can get the knowledge about it. So here if you see the very first picture, it shows that there are so many radiations over here, right? So that is how the radio signals are transmitted. And there is only one mobile phone. While in case of the beam forming, uplink beam and downlink beam, what does it mean? It simply means that something which is sent from base station to mobile or mobile to tower base station. So that is like, uplink and downlink beam, and this is like how it is happening in 5G networks. This is done through the signal processing. Okay, so how it is done? It will be just first. It will be, beam alignment will be there, and there is only one beam into the target cell only will be sent. This is how this beam forming is done in this 5G networks, which saves a lot of energy, because once you transmit so many radio signals in so many different directions, definitely the energy will be lost. While if you are just sending to the targeted cell, it will be saved. So this is another mechanism in case of the 5G networks which is used. Okay, so now I'm coming to the motivation of my research area. Yeah, go ahead, please. Okay, something is written over here. I don't know what is written. So let's talk about what exactly I'm doing. So we are actually targeting to find out the power efficiency of our model. There's a lot of people are working in this area, but as a mathematician, a very few people are working. In India, especially, I think 2 or 3 people are working in this area, especially in this one. Though stochastic modeling and queen theory, lots of people are working. In South also, Professor Krishnamurthy's whole group is there who are working in this area. Then what exactly we are doing? We are just thinking about, see, when I'm going from one state to another, mobile phone, how it is working, it is going from one state to another. If I'm just talking about the discontinuous reception mechanism, the mobile phone right now, let's assume that it is in the sleep mode. But the next moment, once the timer is done, it will be go to inactive mode, or it can be in the active mode. So the mobile phone transition from one state to another, there could be another state could be beam forming, when actually the mobile phone is finding out the beam from here to the base station, right? So this user equipment, this mobile, right now I'm just talking about the mobile phone, but this user equipment could be anything. It could be any other IoT device. So it is basically going from one state to another. Now this straight transition is containing the random phenomena. It's not having the deterministic phenomena. I'm not sure that whether I'm going to this direction, this particular state, or I'm going to another state. So there is a probabilistic or the random phenomena involved. For such type of state transition, we need the stochastic modeling. We cannot proceed with the deterministic modeling. For such stochastic modeling, we are having stochastic process. You must have, some of you, anyone is having an idea about the stochastic process? Okay, forget it. Not an issue. So the whole idea is any random phenomena we want to study, which is very much needed. Any mathematical model, if you talk about the mathematical biology, after a certain stage, you need to have this idea about the stochastic process. Do read about it, and of course, one should have a course in optimization, that's operational research, in which a small portion of stochastic process should be there. I mean, it could be an elective for the MSc student, but that's a wonderful subject, and even for the computer science people also, even for the probability and statistics people also, this operation research course is very, very important. Let's say if it is not there, then of course NPTEL, there's a lot of lectures available. You can always write either to me or Professor Dhamraja. You can always ask if you need any guidance, if you need any guidance regarding that. So if you really need to do any mathematical modeling in real life scenario, see, you can have any type of general modeling, deterministic modeling, but that's not the realistic one. So you have to go with the operational research, and especially with the probabilistic approaches, and or either the probabilistic approaches or the soft computing approaches, or otherwise the machine learning and all. So you can think of studying through the NPTEL also. Now coming to this point, since from one state to another, this mobile equipment is transited or transition is there, so definitely the random phenomena is available, and then we study through the stochastic process and probabilistic approaches we are using. In this particular model, I'm using the semi-Markov approach, but definitely I'm not going to tell you about anything about this, because that's really in a different platform, on a different platform. So go ahead, please. Next slide. Okay, fine, fine. So let's stop over here. So if any of you is interested in any kind of application, you can always write to us. My email ID will be there with Professor Venkataraman. Or otherwise, the Central University of Rajasthan Data Science and Analytics Department website, everything is available. My phone number and my email ID both are available over there. So you can have a look over. If you need any kind of guideline, you can always write to us. Mention that you have attended this conference, and whatever the way we can suggest you and guide you, definitely we are there for you people. So here I'm stopping, and I'm just telling you, like, we are basically working with the power efficiency, so developing a different type of models, whatever is available in literature, recent work. This is actually done in last 3 years. I mean, not mine. Mine is very recent. But in this area, people are started working in last 3 years only. So they are developing the models, and then we are comparing our model with those models, and we are seeing that, okay, power efficiency is really great in our particular model. We did all the mathematical computation. We used Python over here, and we used MATLAB over here, and through that we compared, and we got that, yes, definitely, and actually we are getting very good results over here. So now you understand that what type of power mechanism in 5G networks are available, and how the power efficiency one has to look into. So with that note, I'll just stop over here. Thank you so much.
Thank you, ma'am, for your wonderful lecture, and also motivational to our students. This is a new topic, and we are also moving towards the topic. More budding researchers will do under this topic. Thank you, ma'am. Thank you. Any questions? Audience, from any questions? Researchers? It's a new dimension to do the research. Any researchers?
Right now, yeah, of course, people are working in this, in this work as such. We actually working over the power efficiency of the user equipment, but now people are, I mean, not just people, we are also working in the direction there, in which we are talking about the power efficiency of the base station itself. Because so much radiations, then definitely it's, cooling parameters needs to be checked on. So that is again another one. And the third direction could be, when we don't talk about the terrestrial base station, the base station itself will be in the air. And that's called, which is the recent one. We are having a collaboration with the Russian people, as Professor Dwaraka yesterday told you people. So there the base station will not be on the ground. The tower will not be here. It will be actually floating in the air. And there itself the call will be, everything will be taken care. Why it is needed and why it is important, just think about if there is any catastrophic, the base station is damaged, right? I think just 2 years back in Punjab, in Haryana, I think this Airtel tower, it was damaged and there was no call, nothing. So such type of situation can be taken care by this high altitude platform base stations, which I told you that it is in the air itself. And another situation could be when we talk about the hilly area or the icy area, like especially the Russia people. They're suffering because the terrestrial base station, it's not that easy for them. So they should have something which is floating in the air. So there are different directions of the research. If somebody wants to explore such type of direction, of course you can write to us. Thank you.
Thank you, ma'am. Thank you.
Jai Shri Krishna. Good morning to one and all present here. I, Dr. S. Goverdhan, here to welcoming and introduce today's speaker, Dr. T. Robinson, Associate Professor and Head, Department of Mathematics, Madras Christian College, Chennai. He has been on the teaching faculty since 1987. Sir had received the PhD degree in mathematics from University of Madras in 2001. Sir has authored or co-authored research papers in the field of interest, which includes math systems, picture language, tactile geometry, universal tool design, and bio-inspired computing. During 2000 to 2007, under the DST JSPS program, he visited Institute of Disability Sciences, University of Tsukuba, Japan, for research on disability science and obtained the PhD degree in 2007. Sir had received a national award in 2005 from the Ministry of Social Justice and Empowerment, Government of India, for his contribution in the field of welfare of persons with disabilities. And Sir had received an innovation award from Confederation of Indian Industries, CII Tamil Nadu, for his work in tactile mathematics during 2009. Sir did his postdoctoral research at the Department of Computer Science in Liverpool Hope University, UK during 2009-2010. Sir is also the visiting research fellow at the Department of Computer Science in Liverpool Hope University, UK. With this introduction, I request Dr. T. Robinson to deliver his content. Before that, I request our HOD to felicitate Dr. Robinson with a shawl and memento.
Good morning and thanks for the nice words. At the outset, I want to thank the management of Vaishnav College, and especially my longtime friend and head of the Maths Department, Dr. Vaishnav, for inviting me. Second, I remember doing a presentation at a conference during the Corona time, but this time offline. It's really far better than doing it online. The last talk was on 5G and technology, all that. This will be more of a theoretical, and I'm happy to see some of the PhD students sitting here. I have made some part which is very preliminary, so I hope the PhD students will benefit from that, the content. So I have put the topic as recent developments in syntactic picture recognition. Okay, so this is based on automated theory and formal languages, so it's a more of theoretical study. We have to acknowledge two big personalities before talking about automated theory or formal languages. One is Alan Turing, who gave the framework for automation in the 1930s. And later, little later, Noam Chomsky, who gave the grammatical formalism. And these two personalities had worked on two different areas. One is automated theory and the other is languages, formal grammars. But both were supplementing and complementing each other, giving rise to the area of theoretical computer science. So the automated theory had the origin from the way the brain functions, the circuit, and so Alan Turing, basically a logician, he gave the formalism. On the other side, as I mentioned, Noam Chomsky, he worked on how the language is processed, how we communicate. So he gave a formalism for the grammar. And so both areas together, formal learning and automated theory, will give a scope for a study on the capabilities and limitations of algorithms that can solve problems, algorithms that cannot solve problems. I mean, limitation, how far we can go. So I have formed a presentation in this order. I talk about some definitions of automata, formal grammars, and then I give some variant machine models. I focus on two models, find automata and Bushin automata. Then I want to talk about what is a picture, what do you mean by picture. Then talk about two machine models that can recognize pictures. And then I want to compare these models. So first, few basics. By a symbol, we mean a character of one entity. It may be a symbol like A or B or a star or a hash. By an alphabet, we mean set of such symbols. It has to be finite. When A, B, C, D up to Z, there are 26 symbols, we call that English alphabet. The same way for any language. Just pick up all the symbols, put as a set, we call it alphabet. By a string or by a word, we mean arrangement of these symbols, a finite arrangement. For example, the word A, B, C, A, B, C, B, A is a string or a word. Definitely has a length. Suppose there are three words A, B, C, three symbols A, B, C, then this string. A longer word, much bigger. How about a word of length infinite? It is possible to define, but in practical use we may not deal with words of infinite length. How about word of length 0? It is possible to define mathematically. A word of length 0, we cannot write it, but we can use notation say lambda. Lambda means a word of length 0, which you cannot see. Okay, when a word is given, you can talk about the first part, which is called the prefix. The later part you can call the suffix. Okay, now I want to gather a set of strings, put it as a set, that I call a language. Suppose I just pick the four words, A, B, 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 A. Just four words. It's a small set of four words. I can call it a language. So by language I mean collection of strings, collection of words. But here you find I use a special notation. When I have the word A, B, B, C, I find three consecutive copies of symbol A, followed by two copies of B, and one occurrence of C. I can very well express that as A cubed B square C. This is not mathematical algebraic, it is the language theoretical expression. By this expression we mean three copies of A followed by two copies of B and C. Okay, now I have given some set of strings, a set of strings. I find many set of strings, many languages. Look up here, A and B are two symbols. I call the set an alphabet. I give a name sigma. Sigma is an alphabet with just two members in the set. And here I'm trying to find all possible strings out of this A, B. Just pick that A alone, just pick the B alone, or make two copies of A, or one A and one B, or two copies of B. So I'm trying to find all possible strings of all possible lengths. I'm exhausting. Then what is lambda? When you don't pick up any symbol A or B, there's no string. Otherwise, the string of length 0. So I have to include that also. Lambda is notation. So sigma star is a space out of this alphabet. From this exhaustive space, I can pick a collection of strings. Here I have chosen strings of this type. I call set S1. A different collection of set strings, say S2. So I can form many sets out of this space of strings. I can call them language. Look up here, AB, 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 AB. So I'm just picking words of certain pattern. I won't call this a language. I can express this as AB occurs one set, AB occurs twice, AB occurs three times. So it's possible to express notation like this. So I can really make languages out of a set of words from this space. Okay. Some more examples. if 0 and 1 are the symbols of an alphabet, I can give many examples. In fact, here the S7 is a set of palindromes. Now going to machine model. How many of you have studied formal language or automata theory in this group? Oh, that's nice, very nice. So you just recall this definition of finite state automata or FA. It is basically a abstract machine model which has got 5 essential elements. We can very well pictorially represent that 5 this way: set of states, set of input symbols, then transition mapping, start state, and set of final states. And you can very well express pictorially, like you can imagine that this is tape with all these symbols printed on it. That will be a control, and there's a kind of an arrow or a pointer that will point at a symbol at a time. Based on the control, the delta mapping, you can move one symbol at a time, keep moving right side, and I'm scanning the entire given string. If it is made to reach a final state, the whole word will be acceptable. Suppose the machine gets stuck in the middle, or there's no way it can proceed further, the word is not proper, it's not acceptable, rejected rather. So here's a simple example of FA or FSA. I'm having strings of this type. I should have n copies of 0, just 1, 2, and then m copies of 1. For example, 0, 0, 2, 1, 0, 2, 1, 1, 1. We want to find a simple machine model which can accept any string of this form. In fact, we have put all the 5 components this way. There may be many machine models, many FA, but this one among many. It must have at least 2 states. These are the input symbols: 1, 2, 3. There are 3 mapping functions here mentioned. Q1 is the start state, and Q2 has the final state. And we can very well draw that mapping with the help of some vertices which indicate the states, and movement or the transition with the help of arrows. So this is called transition diagram or transition graph. Or I can use a table column, set of all the symbols as columns, the states as rows, then the movement I express here, either transition graph or transition table. We have to start with Q0 with a word on the table. I have randomly put the word 0021. Well, it's a very simple word. We all know that it's very much in the language, so the machine should be able to accept that word. So when all is set, Q1 is the start state. It keeps scanning one symbol at a time, and once it reaches the end, it is going to the final state, which declared already Q2 is final state, which means the word is said to be accepted. Suppose I give another word which is not in the language. Okay, this being a small word I can know, but so it's a bigger word I need not check. Just run the machine on that one. It keeps scanning and checking. And when it comes here at Q2 for 0, nothing's defined, so the machine is unable to reach the final state. This word is not accepted or rejected. Okay, I made a small change here. Okay, this 0 power n to 1 power n. What if I make this m as n? N copies of 0, just 2, and then exactly n copies of 1. If I put that condition here, it will make the machine, it will ask the machine to check whether you have done exactly n copies of 0 and n copies of 1. It needs an intelligence for the machine. But the FSA doesn't have this memory capacity to remember or recall, so we find that it's not possible for FSA to recognize or accept this language. It's beyond the scope of the machine. So that's why we go for a machine that can have some memory. So we talk about FSA built with a small memory, which is called stack memory, which means for every move it makes, it will make a record of its behavior on a separate library or a stack. So for every move it makes, it may record something, so that at any point of time, it has some information about how far I have come. So let's just see this. So these are the 2 things that we have added to the FSA: a stack alphabet and a start stack. How should we start in the stack? Okay, I'm not going to go into detail. Just one example here. A power n, B power n. It's a very standard example. N copies of A should be followed by n copies of B. Here I have set FSA with stack, otherwise we call push down automata. So you find the memory or stack here. These are the 5 rules that we put here. You find one extra component coming here, Z0, A, the stack symbol. Also here you have an extra component on the right side. Suppose Z0 is the topmost stack symbol. On top of it, it has to place information, say A. Here it's lambda. That means whatever is on the top of the stack symbol, it has to remove that. Okay. So for this word, for example, say suppose A cube and B cube, how the machine runs? It says that Q0 is start state and Q3 is the final state. Let's see how it goes. I have given both the tangential graph and tangential table. As you observe, keep watching the arrowhead and stack content. It starts. This mapping is applicable. So what happens? It places an A on top, scans the next A. This is applicable. Place one more A on top. So it keeps scanning and it is updating the stack. Once it is B, this rule is applicable where whatever is on the stack, the topmost stack symbol should be removed. So the topmost A will be removed as it moves. Again it removes. So once it finishes, it has Z0 on top. By then it has reached the final state, Q3, which means the word is accepted. Here the stack helps the machine to remember how many A's it has scanned so far and exact number of B's it will scan. Because for every A, for every B it scans, it cannot cancel out. Okay, suppose I have A power n and B power 2n. The idea is simple. For every A it scans, it has to update stack 2 capital A's. So just you put double A's here, double A's here. Let us see how it runs. A square equals 4. For the A, it puts double A's on the top of stack. The next A, 2 more A's. So by now it has stacked up 4 capital A's, and then for every B here henceforth it can just cancel 1 A, thereby approving the 4 B's. Yes. Now, suppose I put this this language, A power n, B power n, C power n. N copies of A, n copies of B, n copies of C. This demands more memory, but here this PDA cannot handle that one. Here again the PDA has limitation, but the good news is that we can go for a much bigger machine, which we may call that as a linear bounded automata, or much bigger than that, Turing machines. So Turing machine is the ultimate machine model which can recognize languages of higher degree. So that gives a hierarchy of the class of machines. All the FSA, you can call the whole family of FSA called subscriptial FSA, which is probably contained in the family of PDA, which is contained in the family of linear bounded automata, and everything is encompassed by Turing machines. So we have given some examples already. A power n, B power n, A power n, B power n, C power n. Then what about an example here? A language which is beyond the scope of Turing machine. Yes, there are languages for which a Turing machine cannot recognize. Which means we have a problem, but we don't have a solution. And there are many such problems. Okay, so we have to really look for computing machines which can go beyond Turing machines. So this Turing computation sometimes has its own limitation. So people look for quantum computing, biosphere computing, DNA computing, molecular computing. So there are other computing paradigms which kind of address some of these issues where the Turing computing is limited. There are other computing models which are trying to help. Okay, so now our focus is on picture. So we are gradually moving to picture recognition. This picture is already, this is already given to you. The FSA must have a input, control, and an arrow which can scan a symbol at a time. Here, I make some alteration, and the name is called Jumping Finite Automata, JFA. The normal FSA, the scanning is done one symbol at a time, and there's a sequential progress. The arrowhead moves from left to right, and there is, in a sense, a continuity. They move from left to right. Whereas here, the machine can jump its arrowhead randomly at any part of the string. So an allowance is given to the arrowhead to jump randomly. In the earlier case, it has to start from the leftmost symbol and move progressively towards right. Here, it has the freedom to just jump in wherever it likes and jump wherever it wants to. Okay, this is BB, CA, CA. In fact, in this string, what's the property that you find? How many A's are there? 2 A's. How many B's are there? 2. C is 2. So in fact, the number of A's, number of B's, number of C's are equal. Okay. I have given the state diagram instead of the table. I just put a diagram here. Let us see how this jumping finite automata behaves on this input. Okay, starting state, yes, and the machine is, because the machine is choosing randomly this symbol. When it's state, yes, scanning symbol A, it is supposed to do the state, it has to go to state R. And what happened to the A now? A is gone. So here, one more enhanced capacity of the arrow is that it can simply remove the content. Whereas the FA, it has to scan and leave it as it is. It cannot erase it. Whereas the jumping finite automata, it is allowed to jump anywhere, and once it scans, it can lift off that symbol, so that A is gone. Next is state R. While in R scanning B, it is allowed to go to state T. By then, that B is also removed. So it keeps removing. And it is scanning C in state T. While scanning C in state T, it goes to state S, which is the final state. You find the double ring there. By then, the entire word is gone. So when it is the final state, if the entire word is gone, that means the word is accepted. This JFA is much more powerful than FA, because this language, where the number of A's, number of B's, number of C's are equal, cannot be recognized by a FA or FSA. So we find that jumping FA has more power to recognize languages of higher difficulty. Okay. So we have seen only one symbol being scanned and lifted. Is it possible to think of a string being scanned and then lifting that? It is possible. We can very well extend the idea of JFA to a generalized JFA. The idea is expressed, so naturally that gives more power to the machine model. Okay. People who are interested in that theoretical study further can very well explore this one. Wherever I have put question mark, these are open problems. This is the operations under which the family of regular language closed, family of JFA closed, family of general JFA closed here. Minus means not closed. Question mark, yet to be explored. So those who want to pursue research on this direction, these are question marks that can pursue the research. Fine. Okay, I'm not touching on that one. I have given some sample of languages. These are the machine models that can recognize. And here you find the JFA. That means these are the tougher languages, and JFA can recognize. If we talk about the Chomsky hierarchy, they're matching to the context-sensitive language. That's the power of JFA. Okay. If you want to see the hierarchy as a Venn diagram, the finite languages are always subset of regular language, context-free, context-sensitive. But you find that JFA is kind of cutting through these three language classes, and JFA cutting through all the four language classes. Well, Now, why should we now talk about such machines? In the inference theory, given set of strings, we want to find what would be the grammar that generates that language. We call the inference theory. These machine models are very convenient to handle and to find or infer the grammar model. We are having a set of languages, a set of pictures. We want to find what would be the origin, how the picture evolved. We want to have a mechanism. We want to find the generative mechanism. These machine models can be helpful to find the origin and the rules that gave rise to this language. There's another topic called desirability. Given a problem, is it desirable to solve the problem? Suppose I know that the problem is not solvable, I don't worry about proceeding further. So if I know I can decide whether the problem is solvable, I will proceed further. If I'm unable to decide, I will not take the problem at all. So desirability issues are very, very important in the theory of computer science. Fine. These are the references for the earlier the preliminary that I have done so far. Now we want to move into the picture language part. Two-dimensional pictures. All that I talked about, the A, B, C, or all the strings of one dimension, which you can just write as a linear string. Matrix is not linear. You have rows and columns. Graphs, they're not linear. Tiling patterns, not linear. So you can call them as two-dimensional patterns, array, or two-dimensional picture in general. So here's an example of, patterns. This is Aisha tiling pattern. Sometimes we call it as Wang tiling pattern, column pattern, tessellation, shrinking triangles, some anomalous pattern. I have randomly picked up some examples of two-dimensional patterns or pictures or matrices or array. Is it possible to recognize such patterns or such designs by some machines? We talk about pattern matching, text matching in the strings. We have a lot of pattern matching algorithms. That's one of the strings, linear strings, for the words. You have a pattern, then you have whole text, you look for the text in that pattern. Searching algorithms. But how do we search a pattern or picture among many pictures? We need to have machine models to recognize the picture patterns. So the machine models are now designed to recognize certain types of pictures. So by picture, I mean generalization of a string to higher dimension. You may wonder, is it possible to think of higher dimension, third dimension? Yes, it is possible. The very mental sponge is an example of a third dimensional. We talk about Sierpinski triangle. It is possible to go for third dimension, high dimension. We talk about hypergraph. Okay, already there are many machines like cellular automata or online test automata that deal with generation of patterns. But here I'm focused on recognizing the 2D patterns. Okay, so the idea is here is focusing on the array, but it can be very well extended for graph, tiles, etc. Okay, let's recall the interest of fine automata. We have all used the word sigma for a alphabet set of symbols. And here you find sigma star. That means all possible words of all possible lengths out of the alphabet sigma. Single star. Suppose I want to think of matrices, arrays that have both columns and rows, then I use the notation sigma double star. For example, if A and B are the two symbols, I can think of a matrix A, B, a 2x2 matrix. Or I can say A, B, then B, a 2x4 matrix. So you can think of matrices of different sizes, n rows and n columns, with made up of these symbols. So sigma double star will talk about all possible matrices out of the alphabet A. Okay, it can be a rectangular array of symbols. We have some n columns and n rows and n columns. In maths, normally do the addition, subtraction, multiplication, division, all that will be performed. But in the language theory, you cannot do that addition or subtraction or multiplication. Rather, you do the concatenation. You can attach two similar looking matrices. Suppose you have n columns and n columns, we can do the top bottom concatenation. If there are n rows and same n rows on the other matrix, we can do attach side by side. So we can talk about the concatenation, attachment, column wise and row wise. Some of the operations that we can perform on array or matrices. Okay, I'll recall this again. The jumping. This is the automata which I have already shown. The normal addressing, which we are very familiar. And the jumping and automata, quick recall, which I have already shown. And every time it scans, it just removes that symbol and it accepts. And the variants also I had mentioned. Now we talk about an array or a picture. Suppose I want to give a color, say red for 1 and blue for 2 and some green for 0. Then I get some pattern. I can think of a checkerboard, zeros and ones. I can think of any pattern with a number. So this indicates some picture over colors or tiles. I just put the numbers 0, 1, 2 here. Which means I can have any number of colors, any number of tiles I can express in terms of a matrix. So say picture, I put it as an array here. This will be my input table. And I have the same JFA here. The arrow will be randomly pointed at any location on the array. Now we talk about two types of jump. One is the normal binary jump and the other is the row jump. Because the machine will be scanning one symbol at a time in a row. Once the row is completed, it is allowed to go to the next row. Once it exhausts all the elements of the row, it can go to the next row. The job is to do a row work at a time and then keep moving. Here there are 4 rows, and in each row there are 5 elements, 5 symbols. And you find some hash. Why this hash? There are kind of markers. They indicate that's the end of that row. We don't find on the left side nothing. Okay, the string we always move from left to the right, and no harm in having hash here also. It's a very basic model. I'm just gonna mention here. It is possible to have hash all the 4 sides, which means the play area is for these numbers. The moment the machine scans the hash area, it will be allowed to get back. Let's see how it functions. And there are 1, 2, 3, 4. There are 4 transition mappings here. The 4 guiding rules. The machine is function. Scanning 0. When it's 0, state Q0. It is supposed to go to state Q1. As it goes, sorry, I think I have. Yes, it is 0. Just look up here. Once the 0 is scanned, it will remove the 0, or it will make it empty. Empty means lambda. Then there's a choice. You can either go to this one or that one. It's purely random choice with the machine. You can choose any one of the ones. Any one of the twos you can choose. So it keeps scanning, and at this stage, all the symbols are now scanned, and now that row will be removed. From 4 rows, 1 row is removed. Now we have left to 3 rows, and it can choose any one of the 3 rows randomly and keep scanning. Okay, that row is gone now. 2 rows. Scanning one symbol at a time, and that row is gone. Left with the last row. Here again it goes. When all the symbols are scanned, approved, it goes. Everything is completed now. So this picture, of course, it's a random picture. The machine is designed to accept that picture. In fact, this is what you find. A language of rows. Each row can have any random combination of 0, 1, 2. So this machine is designed to recognize pictures of n rows and m column n rows and each of size m with random values of 0, 1, 2. If you bring in any other symbol, it won't recognize. Okay, so that's a basic model. Is it possible to kind of, if you want to impose some condition that I want to have some strips of colors in each columns. If you impose, then you go for generalized jumping point automata. So it will scan 3 symbols at a time. It is advised to change either all the 3 or change a very well kind of replace. It is possible to enhance the system with the replacing scan but replace the different color. In that case, the machine will scan the picture and at the end it may give a different output. So if you compare the two models, definitely the single scan is smaller compared to the generalized jumping bent automata for pictures. This is a larger class comparison. Okay. There are many properties, and wherever you find that hyphen, I mean, it is still open. There are areas we still want to work on, which means I mean we can't go for easy example. It takes some time. And okay, the trick is what you find here. No. That means all have been worked out. It's written that this is not closed. Okay. I said it's a basic model. We have the liberty to kind of to generalize and make it more function, having it with more functions. So here, how about making the restriction on the movement or the jump? Suppose you say that it has to jump always on the right side or always on the left side. It's always jump down or up. It is possible. You can very well give some restriction on the jumping time. We are dealing with rectangular array. We may start with leftmost or topmost corner. In that case, you can keep jumping on the right side all the time. Okay, so this is how jumping goes. Sorry, there was a mistake here. So, if we extend the idea, I mean, with jumping on the left or down or up, that creates new classes of languages. You find, I mentioned about the right jump and the left jump. You find a small r, a small l. Any picture which is recognized by a right jump automata can be recognized by a left jump automata. So in a sense, whether you jump right side or left side, the power of machines are the same. Whereas here, the machines that jump always up or from down, they are not equal. Okay, so that really makes us think why it is not so. Okay, then we want to combine. We want to combine both right and down jump. So we extend the operation of restriction. We want to have slightly allow the restriction for both directions. Then again talks about equality and further classification, how they can be classified. Right and down, left and down, they are both equal, whereas you find a division here. In the very beginning of the picture languages study, Ronnie Siromani's work was the foremost work, matrix language. To create a language of matrices, Siromani's model was starting from a single star symbol. Initially, all the rows will be created, and from each row there will be columns generated. So it is like one symbol giving rise to many symbols, and from each symbol there will be drop down of many rows. That is the Siromani matrix model, and that's the foremost or the first model with which you are comparing. So that's for as far as the jump is concerned, whether we jump from left to right or right to left, up, down, all that. But when you start, I said that it can start from anywhere. Then again, we can say, should we start from the middle or the beginning of this string or the array or the end of the array? If it's a string, You can start from the leftmost or the rightmost or anywhere under the middle. If it's an array, you can describe. Should it be on the top, leftmost, top, or rightmost, bottom, or anywhere? So we talk about the beginning, the end, and anywhere start of the scan. There again, it gives different kinds of pictures that can be recognized. Okay, so much of study has been done comparing. That is about jumping fent automata. The rectangular array is a standard array. The idea is now extended. How about if the array is not rectangular? If it is annulus, that is, we have a rectangle but there's a hole in the center. What if the array is made up of triangle tiles or triangular array? What if the array made up of hexagons, hexagonal arrays? So what if they are not regular polygons? So the problem is still open. People are yet to work on those directions. So those who want to proceed, then we will think about these shapes. Apart from rectangular, we can go for triangular or isosceles triangles, hexagon, etc. There's one other powerful model which is called revolving automata. Okay, I go back to the same matrix. Some numbers here, which could be representing some colors or any tiles. And this machine is not jumping, it will revolve. This is called revolving automata. It can revolve column wise or row wise. There are two major categories. Let us see how it revolves. So one is the right column revolving, one is the left column revolving, one is circular column interchanging. I have made some examples here so that it is easy to follow. Okay, here is an array or a picture. A machine is given here. The idea is basic FSA, fine automata. But you find two types of transition. One is the normal delta transition, and the other is del transition, which will make the column revolve or move or shift. So this is a given picture, one of the many pictures in the language. I have put them in the input table, and it has to start from the leftmost column. This is start. Now here you may find some dotted arrow and a continuous arrow, that indicating the delta transition and the del column revolving rule. It is state Q0. It is scanning 2. It will be scanning this 2 alone now. The first symbol. Let's go to the change now. Once it scans, it will be going from state Q0 to Q1. For a 0, for a 2, Q0 to Q0. It's a delta transition. So it's checked from state Q0 to Q0 itself, and this 2, because the red 2 that you find here. So now you find the 2 to 0, which was here initially, is revolved. The whole thing is shifted by one column. This 2 to 0 goes this side. All the columns shift by one position to the left. And now again 2, it'll shift the whole column. Yes. Now you find already 2 to 0, which was initially here, has come down here. 2 1 1 is now the last column. The whole thing is shifting, revolving. Okay. Now scanning 0, but 0 is not here. In that case, it has to move from say Q0 to Q1. And when it's not defined in the arrowhead will move one cell to the right. I will repeat the beginning. Please follow. Start array. Scanning the symbols 2. For 2, this 2 is there. Yeah, it can very well be in the same state. As long as if the red is there, it will allow the columns to revolve. It revolves. Now what is there? Because it's is scanning 2. Now what is the inputs? So it has done 3 shifting of the columns. Now scanning 0, but 0 is not here. Whereas 0 is here. It's not the red arrow, it's the black arrow. For scan 0, it has to change the state from Q0 to Q1. While changing, it will change the position of the arrow once to the right side. And now it is scanning 1. It is state Q1 now. 1. It is this arrow. And you find that every time it moves, the left side is fixed. Next arrow, next row. It is scanning. And the last row. So this has to scan all the symbols of all the rows. At the end, because it has reached the final state, the whole string, the whole picture will be accepted. Okay. This is how you can compare the families of these machines. And I want to give an example. The area of steganography. Cryptography is making encryption and decryption. Steganography is not that type. It hides some information. You don't have to use any kind of keys here to unlock, but some information will be there to shuffle. So here is some information which I convert or give a corresponding representation here in some of zeros and ones. Not exact representation. I'm just kind of trying to give an equivalence mapping here. Okay, so this machine is said to scan this picture, work on it. As it works on, it will revolve this, shuffle these elements, and once it stops, let's see what is shown on the message or the picture. Something's hiding. This machine is kind of helping to decode the hidden message. 1, 2, 3, 4, 5, 6. There are 6 letter mapping here, starting with the 2. It is running. Yes. And once the first column is fixed, it moves next column. Yes. And now second row. Every time it shuffles, you find that correspondingly the message is also shuffling. And now you find there's some message that is seen there. I'm shuffling. We are able to kind of decode. I mean, it's not a big example. Just to kind of see how this machine is capable of decoding. Okay, this one simple word from a language of pictures. It is possible to run all the pictures or all the picture word from this language on same machine. Here again, we have compared the properties of the left column, right column, column indicates all the 4 models. So study is almost done. And here I have the list of references I used. The work by Gimerasi and Restivo, it gives a big survey about two-dimensional languages. It's a good survey paper. And then there are people who worked like Suna, Henning, Solomon, James Manuel, Nagar. Of course, it's only the earlier one. Innovate, this one group. So this gives an idea how a machine can be used to recognize pictures. I want to stop here. I'm throwing open some questions. You can just think of the problems that are yet to be solved. I'll give some question mark here, open problems. And instead of rectangular array, you can think of triangular or hexagonal or annular regions. How you can kind of model these machines to recognize. Which is more machine models here, but there are few more machine models which work powerfully on triangular arrays. I have given my email ID and the phone number. In case you're interested and have queries, and you don't have queries now to ask, you can very well post them. I stop here and then I want to see your questions.
Any questions from the participants? Any questions? If not, we will conclude it.
Thank you. Thank you very much.
I would like to take a moment to express my heartfelt gratitude to Dr. T. Robinson for gracing us with his presence at this conference and sharing his valuable insight on the topic of recent development in syntactic picture recognition. Sir's presentation was both informative and thought-provoking, and it truly enhanced our understanding of the subject. His expertise and knowledge were evident, and we were all inspired by his passion for mathematics. I would like to thank Dr. T. Robinson, sir, for taking the time to prepare and deliver such an excellent presentation. His contribution have made this conference a resounding success, and we are grateful for his participation. On behalf of the management and the PG and Research Department of Mathematics, Dwaraka, Goverdhan, Vaishnav College, and all the attendees, I extend our deepest thanks to Dr. Robinson, sir. Thank you, sir.
A warm and pleasant greetings to all for the second day, third session of International Conference of Applied Mathematics and Computing, ICAMC 2023. It gives me an immense pleasure to welcome our eminent resource person, Dr. V. Saravanan, Vice Principal Academics, Faculty of Science and Humanities, SRM Institute of Science and Technology, Ramapuram, Chennai, for enlightening his depth knowledge on this topic, mathematics using Python. Now, our HOD sir will state our checklist. It's my honor to introduce our eminent resource person, Dr. V. Saravanan. Sir has completed his PhD in computer science from Bharatiyar University during 2004. His research area includes artificial intelligence, machine learning, and software agents. In his credit, he has 80 plus publications in international reputed journals, indexed with Scopus, etc. He has presented many research papers in both national and international conferences, and also guiding many researchers leading to the PhD degree. He has totally 23 years of teaching experience, including 3 years as a researcher in Bharatiyar University. Sir has guided 17 PhD scholars, and as the credit toward funded projects, he had completed with Majmua University and King Abdul's University for Science and Technology, Kingdom of Saudi Arabia, with a total project cost of USD $41,500. He is a senior member of IEEE, life member of Computer Society of India, Indian Society for Technical Education. Sir has worked as a professor and head of the Department of Computer Applications in Karunya University, Coimbatore from 1999 to 2009. He also served as a director, Computer Applications of Dr. NGP Institute of Technology, Coimbatore. Currently, sir is working as Vice Principal, Faculty of Science and Humanities, SRM Institute of Science and Technology, Ramapuram, Chennai. With this short note, I welcome sir.
So nice to be here as part of your conference. Uh, so I am an odd man out because I'm not much into your field, mathematics, but instead I'm going to show you a few interesting, things where we can think about using it in a more, technology-enabled way. So, but particularly I'm working on, artificial intelligence. In artificial intelligence, we do a lot of research on machine learning and deep learning. Without mathematics, we cannot do anything in the AI research or in the computer science research that what you're talking about. So of course, basically I've completed my undergraduate in mathematics, and after that moved to the computer science, and still, using the core mathematics concepts in the research. And today, what I thought I can just share it with you about, so a few important, technical things. So, you are listening a lot of lectures, maybe in your class or even the 2 days of your conference. So, a lot of topics, so algebra or calculus or, whatever it is, your broad area of mathematics, core mathematics or applied mathematics. So, a lot of new concepts that you are learning from the researchers or from the eminent, speakers who are sharing their valuable expertise to you. Okay, so I'm not going to talk much about, or I'm not going to, touch the mathematics, core mathematics at all. Instead, I'm going to just tell you how to, make use of this concepts of mathematics and see that visually. That is what you, the things are, gaining momentum. Right? Wherever we go, the people are talking about data science or data analytics. Even, the tech companies are concentrating on targeting the mathematics students, or they go for the campus and they need only the mathematics students and recruit for the data science or data analytics, and they give the training on a lot of tools. So for the next 45 minutes or 50 minutes, I'm going to show you a few work done already I worked some problems. That problems I'm going to show you and to see what is available, and the codings or whatever I'm going to show you to you. I'm just leaving the coding here in the desktop. Maybe you can think about copying it and practicing it. Of course, we are going to use some kind of tool. That is what is needed here. Of course, every day, everywhere you go, they are talking about artificial intelligence or IoT or Python. So computer science students, they will tell, sir, I'm learning Python, or we are learning the artificial intelligence, or they use the Python for the implementation of AI. Lot of things. So this language Python, is being used in all the areas, or I can say in all the disciplines. But the core here is the mathematics. Is it possible for you to solve some of the problems of mathematics using Python? Right? That is our question here. You can think about all the things, whatever you study in algebra, whatever you study in calculus, whatever you study in graphs, all the things you can visually see, you can visually solve it and see the output will be, how the things will be. You are taking such a long time to solve your problem, but how to make use of the computers to solve your problem? There were many programming languages previously, exclusively which has come for the mathematics, starting with the Mathematica, and a lot of tools were there already. But why this Python has gained a momentum, or we talk about it's being used, widely used? The reason here is the applicability, or being it as an open source. It is freely available for the researchers and the students. Right? So this is one of the important thing here. Right? So the codings are available in the internet, or the tool is available for you at free of cost. You can think about using it appropriately for all the courses. So please think about it. Maybe at the end of the session, so try to if you feel it is more interesting, try to see whether you can use Python for learning some of the courses that what you study in this semester, or the courses which you feel interesting, or even the courses you feel it is very tough for you. Try to see whether you can use Python and solve the problems. Okay, so there are some 10 exercises I have. I'm sure that so this 40 or 50 minutes is not sufficient for me to give you the demo of all the 10 experiments. But the copy is here. Maybe 2 or 3 we'll try to talk. Then based on your interest, we'll try to have some discussion on it, particularly on the the technical part. And there are a few things which we have taken some libraries and we worked on the core mathematics. So so let us not talk much about the mathematics. And our discussion will be how to make use of the concepts, algebra concepts, polynomial addition, polynomial subtraction, or polynomial multiplication, or simply a matrix multiplication or a multiplication table, whatever we talk about, the basic things, right? So we'll see how to make use, and solve using the Python. Of course, whenever we talk about Python, the one thing that comes to our mind is the tool. I'm talking about here, I'm just using a tool called Colab. Okay, so Colaboratory. Colab is one of the open source tools that is available, right? It is by the Google and it is available at free of cost for you. If you have the Gmail login, that is more than sufficient. I'm sure that you all have the Gmail login to you, and you can use that Gmail login. You can just type, the colab.google.com or colab.research.google.com, right, which will ask you the credentials and which will you'll be able to see the screen that what we are talking about here. Okay, so this will be your home screen when you try to open the Python. Okay, so what we are going to do here, I'm not going to write the coding one by one. So I have solved some problems already, and that I'm going to upload and just show you how the things are working. So here you can see it is the Python environment that what you are seeing it here. Okay, so all those Python files will have the extension of IPYNB is the extension. So don't worry about it, and you can give some titles appropriately. So here you can see the code part. I'm going to type the coding. Whatever I want, I'll just type the coding here. And these codings are self-explanatory. Right? Don't feel, sir, I am a mathematics student. I don't know anything about programming. Right? So C programming and C++, I don't know anything. Don't worry about it. If you just spend 1 hour or 2 hours, I'll give you some videos, links. So if you see that video, and I'm sure that you'll be able to understand some of the concepts of the basic programming that what we are trying to say. Okay. So here we have the coding part. So what I do here, whatever the program that I write, I'll just simply execute here. Okay. So the beauty here is, of course, whatever I execute, right, this will be executed in the Google server, right? This will be the Google server. I'm not going to use or this Python environment. It is not depending your client or the type of laptop that you have or the type of memory that you do have. See, executing a Python library or executing the complex mathematical problems, it needs a lot of libraries. Even if you want to do something on sine and cos, you need to import a lot of libraries. So that's what I said. It is an open source. So the libraries are already written. So you need to just know what libraries are available. Just pick and choose, right? So just choose the appropriate library and use it for writing the programs. Okay. So here I have the programs which I have already written. So here I'm going to upload a new program. Okay. So that is already available. So here you can see the list of things that what I have. These are all the predefined or the solved exercises that it is exclusively I have prepared for you. So you can see that you can think about using the Python for number theory, right? And all the concepts of algebra 1 and algebra 2, right? There are certain things, right? As algebra as a whole, all the things that what you study, right? You can visually see it here, how the things are getting executed, and we can also think about using the Python for calculus, right? I'll just show you some one or two codes related to that, and particularly next 3 things talks about the Python codes for the graphic environment, for the visualization environment. If you draw a shape, right? Even if you draw a circle, right? It needs the basic mathematics are important here. All the things that talking about, and there is one exercise which is meant only for the probability, and there is one exercise which is meant only for the trigonometry, all the basic shapes. Okay, so let us just upload one basic, code that what I have. So this code is already being prepared, and I have it here. This code, I'm just uploading the code. Right? You can do in this way. You can just upload the code that what is being already given. Okay, so the coding is given here now. Okay, so it's just a simple environment, right? So I'm just using some sort of coding here. You can see it here. This is some sort of a coding a usage, right? So I'm going to import some symbols because mathematics uses symbols, right? Whether it is a plus or minus or all the operators that what you have, right? We refer them as symbols. So how to make use of the symbols? There are some predefined libraries that is already available. Okay, so symbol Python. This is a library that is already available. Number Python. These are all the libraries. Right? These are the subgeneric statements. Right? So, sir, what is available in SymPy? What is available in NumPy? Again, there are some 400 to 500 library functions that is available. Right? Even in some libraries, you can find more than 1,000, built-in objects are available. So, this is what we are trying to talk about. SymPy or NumPy. That is what we are trying to talk about. And there are some, library files that we are just importing. You see that. So this is one of the initial level. So we just run it. It takes some time initially. It takes some time, maybe some few seconds. So here you can just notice that the things are running here. It means that your code is being executed in the Google server. Right? It is just initializing the environment. We try to just initialize the settings that what is required for the Python program. It is done now. You can see a green tick here. So next, there is some basic code that is being written here. You can just see it here. I just want to solve a simple expression in an algebra, right? You want to solve a simple expression here. You can see that expression here, right? So what is the expression here is 2x plus 4 equal to 9. What is the value of x? Right, you have a simple expression, right? So you can do it manually. I'm talking about, you can think about even, converting this into a complex expression and see how long the system takes, and you can check about all the things. So the expression we want to solve is 2x plus 4 equal to 9. So whatever, here I have given is the command line. So the system will not, this is for our convenience. Here you can just say that, I just defined a variable x equal to sym dot symbols. Sym is one of the library that I have imported here. You can see here, right? So sym, and it refers to SymPy. So from that, I just take the symbol x because I'm using a symbol here. Okay. So I just say that expression is equal to, what is our expression? Expression is equal to 2x, that is 2 into x plus 4 minus 9. Right? So whatever you want to do, right, in the Python, you convert it into a homogeneous expression. Right? So, so equate it to 0. Right? You know the things very clearly. So expression is equal to 2 into x plus 4 minus 9. So what I want to do now here is I just want to solve this. SYM is a library that I imported, and there is an object called solve. When you say solve, and the system is going to solve that expression, and and you are going to find out the value x. Right? You have an expression, and what do you want to do that? Right? So, and I want to get the value x here. So what is the value of x here?
2.5.
Right? If you just execute, you are going to get the value here. What is this 5 by 2?
2.5.
2.5. Is it correct? Right? So, this is one basic thing, right? You can think about it just solving a simple expression and try to increase the complexity now. Try to increase the complexity, right? So arithmetic operators, right? And see how the thing works, right? So there are various things that we have, we can think about using it, right? So here you can, it looks more nicer. What we are trying to do here is, right? You can see here what I am doing into the next part of coding, right? The solution here is, right? You can see it here. there are two things. The solution here is 2 into x minus 5 is 2.5, or the solution to 2x minus 5 is x equal to 2.5. You just see the difference between how this line is printed and how this line is printed. Right? I'm sure that you might already have about, or some of you are using latex, right, for using the mathematics or for typing the mathematics expressions or equations. We cannot just simply type it in a Microsoft Word environment. So the latex is a scientific tool that we do use it. So here, you just see how I am printing and how I am printing in the first line and the second line. The way you are printing itself, you can change it. You can see, right? You might have noticed that in the mathematics articles or the books, how they write the equations. We don't want to just simply write as it is, 2 star x. I don't want to write like this. But here, this is the way that I want to write it. Okay? So there is a library called latex. There is a library called latex. We just use that particular library and print it. Right? So previously, what do we use? Right? We use another latex tool itself. That is, again, you need to write a program for that. Now it is very simple. Right? All the things that what was we are doing it in a more time-consuming way. You can just see it here. What I am doing it here. Okay, you can input the equation directly into the solve, into the solve function. Here I am giving the expression as the input. Suppose if you want to give the thing straight away, SYM dot solve x star star 2 minus 4 comma x. Right? You just see, right? You can solve it manually and just check the solution. Right? So here it is. So that there are plenty of things that we can talk about. Right? So I have given you some experiments, and all the things are related to the basic algebraic functions that what you have. Okay. Right? You can just see it here. Right? How I am displaying a simple an equation. Right? So using the mathematics, using the latex functions that is available here. Here I am just defining, right, 3 into q plus 4 by q plus 3 minus 5 into q minus 1 by q minus 1. Right? So you just see it here, Right? So that is the beauty of Python. You need to just know how to give the input and what libraries are available. If you just practice it for just say, so for some 2 or 3 expressions, or printing some 2 or 3 equations, I'm sure that you will be able to get a very good idea about what these things are all about. Okay? So this is one thing. I'll just try to just upload the another thing that what I have. It is algebra 2. Right? So every Python exercise, if you go, there will be some 40 to 50 exercises which is exclusively designed for the students, right? Or maybe the researchers. You can think about here, right? It's again, we talk about creating a list or printing it, right? Creating a list of, or we talk about arrays, or we just talk about matrices, or all the things. Okay. So initially, when you just upload a Python code, it takes some time. Initially, some 20 seconds, or or even not less than 10 seconds to give you the result. But as you progresses, maybe the second and third part onwards, right, it takes only little time. Here you can just see that it is rotating because it has to initialize the library. It has to get imported from the Google the processing engine. We call it as a GPU, graphical processing unit, because it has to import all the libraries that what we talk about. Here it's showing error because we have not done the initialization here. So this is the first code that need to be done. Then if you just execute the second code or second piece of code, you are going to get the answer as 15, 15. Right? You are just defining a list. It contains say 5 elements, 1, 3, 4, 1, 6. You would like to just print it. You would like to print it. We have the print function and which also collect the sum, right? So 15, 15, right? So 2 different ways If you want to find out the product of the list, right, you just give some numbers and you just find out the product. Or if you want to find out, the sum and draw some, graphs, you can see it here. We have some function called plot function, which just plots you some values, right? You can just give the input what you want to have it in the x-axis or y-axis, and you can just prescribe the legends and what you want to have. So here I want to have the list and cumulative sum as a legend, right? So plt.legend. I'm just going to display it here. You can just see it here. There are two lists I am creating, and I'm just mapping the value. So first list, if you just see the first list, so these are the values, 0, 10, 20, 30, 35. Second list, cumulative sum, that, what is the value here. Slowly, the part of visualization. So the things are so easy for you to not only just, implementing some of the mathematics concepts, but also, visually representing it. We talk about visualization nowadays. Right. Here we talk about generate a numerator, right? So we try to, just use some options that is available. You just go ahead, there are many differences that I have given here. Right? If you want to have something related to quadratic equation, if you want to solve something related to quadratic equation, you can just sit here, minus b plus, it is two things, minus b plus or minus, root of b square minus 4ac by 2a. You just define the values of a, b, c, all the inputs you give, and there are two things that, it is one for the plus, one for the minus, right? Then you solve it, you are going to get these values. Right, solving the quadratic equation very easily, right, by using it, right. You can even think about using the complex numbers, addition, subtraction, all the things, right. You can execute and just see how the things are, right. Because I have not executed the previous part, it is showing some error, right? It does not work because I have to execute all the things one by one. If I have given you some, this Python notebook which contains around 70 to 80 exercises, try to see that you are executing the exercises one by one or one after another, because we need to refer some of the good, some libraries, or we need to refer some of the values or variables that is being already defined previously. Okay. So basic things about your Python, sorry, the algebra, and there are a lot of things that is available here, It is for the calculus. These are all some standard libraries that is available, and and we just import the libraries, use those libraries, and all these libraries are available in the Google Colab tool, right? So we try to talk about defining some function and solving it using your mathematics, so the calculus thing, right? So limit x tends to 1.5, x cube is equal to, right, with this value, right, 3.375, right? I just use the LaTeX format, I just do the printing, right? So all the things, if you want to print a function or if you want to evaluate a function, here, I just want to evaluate this function, whatever you defined it, and want to draw some graphs, that also can be done in a more clear way here. Right? So whichever way you want. Right? So solving the calculus functions and plotting it in a graph and arriving to some conclusions. So what is the purpose of all these visualizations are? To just interpret it and see that what best we can derive it, or what knowledge that you would like to share it with you. Because in data analytics, or particularly in data analytics, we try to talk about you know, the knowledge or the outcome. In which way this particular graph, you know, or what knowledge I am gaining from this graph, and what decision that I am going to take, and in which way this graph will help me in making my decisions or will help me in improving my business. It can be of anything. We use this kind of graphs even for the the student data to just predict the student learning behavior, right? So whether what kind of elective courses can be offered to the particular student, or which kind of things. Even there are two sections of classes, A and B. So I can think about giving one set of electives to the section A, another set of electives for the section B, because the demographic details, if you see the A section and the B section, they are quite and it differs. That is what we are trying to talk about. This visualization will really help you in making some decisions. So the first part is talking about using the mathematics libraries available in Python to solve some or all the concepts in mathematics. Number two is the applied visualization part, right? We talk about or those who are interested in in digging it or concentrating or try to move to the data science or data analytics area. So this is one of the options that what you need to explore. So there are plenty of things that is available. So it is again a simple course that is available for you, just to practice some of the concepts of trigonometry. Yeah, it's done. Right, we just try to generate some random values. We just try to plot the values using the random values, right? We try to distribute the random numbers by calculating the mean and standard deviation. So all the things can be done in a more effective way. So you can also convert the radians and degrees. Right? So 180 degrees, 3.14159 radians. So by just having a simple input, by just simple conversion, right? Pi by 180, whatever the things that you have, divided by 180. Right? Even the Pythagorean theorem, you can solve it by defining whatever the needs, whatever the input that what you want, right? Right, whatever the input that what you want. So you are solving it in class, but if you could solve it using Python, you will be able to get a clear idea about what this is all about, right? The Pythagorean theorem. And you can change the values always, right? Suppose if you feel like, sir, I don't want to have the A as 8, I want to change the value of A as 10 and say B as 6, and you want to execute this further, and you will get a result. This result is going to be something. Right? Keep changing the values, inputs, and try to see what best value that you will get it here. Right? Suppose if I am going to get, suppose some abnormal value if I give, suppose if I give the value of A as 1000, and let's see how the thing works here. Right? So you know what the Pythagoras theorem talks about, you know the triangle, and you know what value you have to give for A, B, C. Okay? And that is what we are trying to talk about. We try to fail the system. If you give the wrong input, the system will give you the wrong output. Okay, so be clear about what values we can give here. What values we can give it here, right? Or we'll try to reduce it now. Say this 1000 to 100. Let's see what's the value here, right? Of course, it is not also good. So try to just see whether you can give 50 and you get a triangle, right? Or if you increase the value of A, increase the value of B also. You get some value here, or you just say let me give some 40 for B, right? Just get some meaningful things, meaningful figures, right? So that is what the beauty of the using the coding or softwares, right? Give correct inputs, you will get the correct outputs. If you give wrong input, the output will be wrong. Suppose if you give correct inputs and system gives you wrong output, it means that there is some problem in the system. And even otherwise, if you give wrong inputs and if the system gives you correct output, again there is a problem in the system. But here everything works fine. You just check for various combinations here, right? Solving the Pythagoras theorem, right? Solving the complex things, right? So all the things are available here. Maybe as you get a free time, you can just think about opening this and uploading it in your Gmail or in your Colab, right? And you can solve it. Okay. And there will be two files. This one file is the solved one, and the second file may contain some bugs, some small corrections that you have to make it. That is for challenging you with some simple task. And here I'm just using the first exercise, which is solved fully, right? So that you will get a clear idea about what this process is all about and what are all the sections that is available for us, right? So as usual, initially it takes some 10 to 20 seconds. So you cannot open too many, notebooks or too many Python codes from your Google account, right? It shows the session timeout or terminating the existing session, that whatever it is. I've just done it, right? So you just it is simply plotting the values, right? So you just have the value x equal to 3, y equal to 5. You just plot it, right? X equal to 3. Here, x equal to 3 and y equal to 5, right? Just change the values and see how the things are, right? Suppose if you give the x equal to 1 and y equal to 5, see what is the result here. The things are moved here now, right? Suppose if I give x equal to, say as usual, right? If I try to give some abnormal values, right? Let us see how it works. Right? So automatically, the square size is very important here. Here I define the size as -6 to +6, right? So you just keep changing some things, some parameters. The coding will work very nicely for you. Keep that as the master copy, and as you make some changes, keep changing the values of x and y and try to see what is the input that what you are getting. If you give 5 and y as 5, I'm sure that you will get some results. Right? So if you are going to give some abnormal values, it may not work, because the problem here is, suppose if I give here 50-50, so the axis, the total plot size is -6 + 6 and -6 + 6 in both the axes. So if you want, you can just change even these values and try to see how the things are working, right? Here we talk about set of coordinates, right? A very simple thing, right? We just need to have only one line of program and a for loop. That's it, right? And I want to have a square grid, right? And the results are given here. All the things are. So what is 0.0? What is 0.1? You can just say that, right? Those who are studying statistics, you can think about interpreting this in a more meaningful way, visually representing it. Or those who are doing some research, right? Or the student papers, most of you are participating in some events. Try to see whether you can solve some of your interesting problems in mathematics or in any one of the course that what you're studying using the Python, right? The solved things are already available here. Right? So different things that whatever it is, right? You just draw a line. Just draw a line. Fine. Okay. So the it is not just simply using some softwares like Excel or something to draw your line. You can draw this line very easily, but as a mathematics student, you need to break your heads and see what are the concepts that you have to use in here, and and of course a little bit knowledge about computer science, a little bit knowledge about all this programs. If you just see, it is only the extracting the libraries. That's all, right? Maybe if you just practice it for 2 to 3 hours, I'm sure that you will be able to understand these concepts in a more better way, right? So dividing this into 4 quadruples, Q1, Q2, Q3, Q4, and wherever you want to plot it in this way, right? So starting from basic exercise to advanced exercises, all the things are available. There's something different, right? Something different, something innovative that what you want to do. Some different chart that you have never seen. Suppose if you feel like, sir, I want to draw some chart which is not available. I want to draw the chart on my own and by adding my own colors. But main thing here is what inference that you are making out of this, graph is very important here, right? So what do you want to do it here? That is very important. You can change the colors and you can change the style or whatever that you want to do it here, right? All your linear equations can be solved. All your rational functions can be solved. Here I have given you. You can use, maybe you can plot all the functions using the SymPy libraries that is available, right? So you can think about making some pictures from mathematics, from the matrices that what we are trying to talk here, right? You just see it here. So it is, see, this is it's a 2 by 2 matrix, 1 2 1 4, 1 2 1 4. You can just see here this column, right? The same number 1 1. So wherever there is a same number, I want to have a same color, right? It's 2 4. So this matrix in visual form, right? Matrix in visual form. Something bit interesting for you to solve it, right? Maybe you can use it for your implementation. So you can just see it here, another thing, right? So having drawn a very large matrix, you can just see it here, and connecting some 2 points, or connecting the points where you feel like there is some associativity. Okay, how a particular student is related to another student. Is there any common or is there any similarity between this student learning pattern? Right. So we have done this as a part of our research. We found that the students who are coming from the rural background, they are poor in the programming skills. They are poor in the application skills. Right. So, but the student, that the same student, when we ask them to do something in mathematics or Tamil or English, they are doing it well. But the same student, when we ask them to write the, coding, they are not able to do. The students who are living in city, some of the students, they find it very difficult to learn the languages, or say Tamil, right? They might have studied, some of the different language. So we would like to relate, some 2 set of students or 2 set of classes or 2 faculty members. There may be some relation. What is that relation is all about? One such interesting thing that what I found is I was sharing to you about the mathematics or the programming ability of the students. There is another set of students that what we found is that there are some set of students, right, from the 2nd year and 3rd year of our classes. There are some set of students. These students are always dominating the complete show in the class. There are 7 students we have taken from the 2nd year. There are 5 students we have taken we have identified in the 3rd year. These 12 students, right, are dominating the complete show. When I say complete show, these students are the one they get the first mark in the class. These students are the one who will come forward in attending or in organizing some activities. These students are the one who will come forward in learning some technologies or preparing some projects, right? So when we just see that another aspect of, the interesting thing of the students, all this 12 students have studied in the same school starting from their LKG, right? So starting from the LKG to the 12th standard, and they again joined in the college with the same branch, and some sort of relationship that what they have, some sort of positive vibration these 12 students have, and they always move together and they always work together and see that something is being done. So some kind of interesting pattern, some kind of interesting conclusions we can draw by having completing this kind of simple things, right? So you can think about a lot of things, particularly in Python, right? You can create a checkboard. You can create a checkboard, right? You may think that it is very complex, sir. It is very possible, sir. I'm a non-computer science student. Sir, enna poi oru program eludha solringla. No, it is not possible. Don't think it that way. You just see how many lines of codings are here. 1, 2, 3, 4, 5, 6, 7, 8. 8 lines of coding. 8 lines of coding. 8 lines of program. Right? If you just do this, right? So the output will be a checkerboard. Right? Chessboard on that, right? Now chessboard on that, right? What is the next step? Right, coins. That's a library. Then keep playing. You can develop a chess game. You can develop a chess game. Some of our students have developed, this students that what I'm telling, they have developed 15 such games. 15 such games using the Python, and they have uploaded in the Play Store. Right? It is available for the rate of say 100 rupees. The students have converted this under business, and every month the students are getting around 20 or 25,000 income just by the apps that is being downloaded from their accounts. Right? See, one thing is you learn something, and number 2, related with the technology. Number 3, try to convert this under business. Right? It's a future point of view. Some of you can join together and do this kind of things, or you can join together with some of the students who are good in computer science. Right? It is an interdisciplinary thing. Suppose you feel like, sir, program sir, but I will give much of the things in mathematics to my friend who is studying in computer science. Go ahead. Right? So go through your department, your faculty guide or your head of the department, and to their head of the department. There are a lot of things that we can think about using it in a more appropriate way. So what is the size that what you want to give? Right? Here I have just said 10-10. Let us see 20-20. Right? When I say 20-20, right? We will just see what is the input and what is the problem here, right? 20-20. So it means that there is some problem, right? When you change the value, you have to change the value in many places, right? You have to just see how the things are, right? We'll get a 20-by-20 board, right? 10-by-10, 20-by-20. Simple, the chessboard contains how many, boxes. You know that, right? So aduk badala innoru check box, so miniature money the students have developed. 5-by-5 student develop panni. Avangale or game develop pannittaanga. They have their own rules and regulations, and they named the 5 student develop panni. So over student first letter eduthu they named that particular app, and they are selling this for 50 rupees in the Google Play Store. 50 rupees da. So many of them are buying, and they do get very good money. And we can see that even our third-year students, they are able to generate some income for their thing, and they are very happy, sir. I'm able to satisfy, and we are buying a good mobile phones, and we are able to buy good bikes for our without without disturbing our parents. Something like that, that is what we are trying to talk about, right? So there are plenty of things that we can do, using the Python. Right? You can just see it here, drawing the patches with the polygons. Just see it again, a 7-line of coding. 7 lines of coding. Just simple things, and what libraries are available and how to call the libraries, that's all. Right? Already, to draw a polygon, there is already a program which is written, and it is available as a library. You need to call the library, supply some parameter, right? So I need to draw these two polygons here. So one maybe in purple color, another in blue color. So with this much a degree or as a right angle triangle or whatever it is, and with this much tilting, all the things you want to put it in a square, all the things, right? So you just do some, you just observe this small diagram which is given here. What observations we can make? What is the value in x? What is the value in y? And two triangles are there, and one is in pink color or purple color, and another is in blue color. Right? I'm sure there is a right angle triangle, right? Or A, B, C, whatever it is. Define this properties. That's all. Right? And what color that you want to have, you can choose it here. All the things. Right? Right? You want to draw a graph like this, a simple graph, right? And you want to have something. You want to highlight there is some problem here, and you want to address it here, right? You can say that, right? You can export some graphics as pictures here, right? Right? So a lot of things are there. So just see how best we can make use of this graphics option that is available. So it is available in the name, Python mathematics, graphing, graphing codings, all the things, right? Again, a very simple thing regarding the trigonometry. Right. So first, just run the first initial course for importing the libraries. Right, it's done. I just want to draw an asteroid radial, radial curve here. You want to draw a curve, right? So this we call it as, right, asteroid radial curve. What it is, right? Just see what is the two mathematical functions we are using it here, cos and sine, right? Those are applications of mathematics here, right? Where the sine function is being used, where the cos function is being used in numerous areas, right? Particularly in drawing this line or drawing this small diagram, where the sine function is used, where this cosine function is used, right? You know it. You know what is a sine wave? You know what is a cosine wave? Sine wave நீங்க repeat பண்ணி போயிட்டே இருந்தீங்கன்னா you know what you will get it, right? Everything you can change it as an abstract type here. You can see it here, right? It is another diagram. Three different things, three different shapes. Again, a radical curve with a lot of different changes. I'm just plotting it, right? You want to draw some rose curves here. You want to draw some rose curves, right? So நீங்க கோலம் போடுறீங்களே அந்த மாதிரி you can think about it, right? Some of you are good in drawing this column, right? So try to develop a program for that. Right? Try to see, you draw the column in your notebook and just see how many circles or intersects or how the things are there, and start developing from this. Now you know how to draw this. I have given the coding. So either just you can think about enlarging it and developing as some design. All the things I've given is very, very, very abstract in nature. Very, very abstract in nature. You can just see the things on here. Abstract things. I'm just drawing it around some 9 different images here, 9 different outputs, starting with the circle, and just see how the things are just moving it, and which one you are convenient in, which one you want to go ahead, right? So finally how it comes here, right? So what sort of things, or if you want to draw a square curve, that is square plus circle, you want to draw something like this, right? Square plus circle, right? Or you want to draw some logarithmic spiral, Again, all the things, most of the things, if you just see, it is completely, the cos, sine, and the exponent functions. Completely the cos, sine, and exponent functions. Right? By seeing a particular abstract type, you should be able to tell what sort of functions is being, what sort of mathematics functions are needed to draw this. I just want you to draw the image of this pen using the Python. I just want you to draw the image. Right? By seeing this, you should be able to say, yes, sir, we need sine function, we need cosine function, we need exponential function here, we need logarithmic function. So this is what is needed. Right? Because as a mathematics students, you are good in that. But we find there is some small gap between this, the knowledge that what you have and the knowledge that what our computer science students are having. Right? They are good only in programming, but they are not good in mathematics. They have studied mathematics, right? But they are not using it appropriately. When we ask you to design an abstract type of this pen or a cap, you should be able to say, sir, these are the functions I needed, sir. Go ahead. That is what is really important here, right? So plenty of things we can do, plenty of wonders we can think about using it in a more appropriate way, right? Again, a very simple diagram, an abstract type here. Sir, what is the use, sir? Why we are, why you are showing all those things? Or, it is just playing with the sine and cosine functions and the exponential values that what you have. You can just see it here, right? It is completely the cos and the exponential function. That's all, right? Just use something. So this will show you some logistic map. Let's see what this logistic map is all about. Right? This is not that. This is not completed. Right? Another one. We have done the maximum. Then the last one is the probability. So not only mathematics, but also in the probability and the statistics, right? So we have the libraries. We can think about using it in a more appropriate way to draw the histograms and find out the probability densities in the data. You just see it here, right? How the things are, and we just have the numbers, and not just simply copying and pasting that numbers and drawing a bar chart or a different type of charts in Excel. But I want you to use the Python to draw the charts on your own, right? So maybe some good observations you may get it, right? See how the things are, how the data is distributed using 6 different kind of graphs, 6 different and the beauty here is all this library, all this 6 different graphs are available in a single library, right? So just you should know the name of the library and the type of function that you are going to access it, or the type of the parameter that you are going to supply it, right? And here it is virtual coin toss. You are going to toss the coin, right? It is going to be virtual, right? Heads and tosses, whatever it is, right? Heads and toss, right? So I'm just, it is a probability, right? It is, the blue talks about fair, and another one is called biased. Right? What is the probability here? Just get complete there. Right? All the things, starting from building distributions to random numbers, here I have given. I'm sure that some of you PG students at least studied something related to central limit theorem on probability, right? Joint probability distributions. all these things can be done. And the final thing here is, what I want to say here is, this kind of images you might have seen somewhere. Where? This kind of images you might have seen somewhere in the medical field when they're taking the MRI or any CT scans, right, of our human body, right? So you might be seeing this kind of images here. Okay, just see now how and where the mathematics are being used, right? So I'm sure that some of you have already have this MRI images with you or CT scan images with you in your home. Just see these images and just see, if you want to develop this kind of images, what kind of mathematical concepts that is needed basically. What kind of mathematics concept that is needed. If somebody asks you, you should be able to tell. That is the need of the day. That is what we are talking about here, right? All the things, your probability or your distributions and whatnot, all those things. So here I have, okay, and all the things are available here in your desktop. I can just say, mathematics using Python folder, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 solved exercises. I'm just leaving it here. Right, 10 solved exercises. You can just copy it. Maybe once the event is over, through your teacher, and get it practiced through any one of the platforms that you are comfortable in. Sir, in a Google Colab, when I'm good in Jupyter or any other platforms, you go ahead. But what I want is, right, so by the end of the semester, now I'm sure that you are in the middle of semester, at the end of this semester, if you could say, sir, we have developed some set of a Python course for some of the courses that what I study, so we'll be so happy to hear this kind of news. See, one thing you be clear, so we cannot run away from the technologies nowadays. Sir, why you are forcing us, or why you are asking us to learn Python? Sir, I want to study mathematics. I want to teach mathematics. But why this? Because it is the need of the day. And if you are taking some time, and if you learn this, and if you really master in this, I'm sure that for the next 20 to 30 years, we are going to talk about AI, and we will be using the AI in all the fields. When I talk about AI, it is a mathematics only. We are talking about artificial intelligence in agriculture, artificial intelligence in business, AI in healthcare, AI in education, AI in transport. Right? This artificial intelligence is being it is being used in all the fields nowadays. Right? So we cannot go by leaving the technologies. Yes? You all have mobile phones. You all have the email IDs. You all have the websites. Some of you may have websites. Right? If somebody asks you, what is your mobile number? If you say, no, I don't have the mobile number, you will be the odd man out there. Isn't it? Some of you may have 2 SIM cards or 2 mobile phones. Just see how we are addicted in using this technology. Somewhere or other. Whether you like it or not, you should have a mobile number. You should have the Facebook, or you should have the Instagram, or you should have the WhatsApp. Right? Lot of things are going on, Right? Somewhere or other. Right? Next day itself, yes, I also want to show something, and I also have a new mobile. And every day, or every month, or every year, you can see new generation of mobiles are entering inside the market, and where we are attracted, and we are using a lot of, somewhere or other we are spending a lot of time with the technology. Right? You know it. So per day, how many hours you are spending with the technology? You ask yourself. I don't want your answer. Right? All YouTube, WhatsApp status status reply, you know how much time you are spending in this technologies. 1 hour or 2 hours or 3 hours, right? So the student says, sir, I will work up till 4 o'clock or 2 o'clock or midnight. I will see YouTube shorts, reels, Instagram, sir. That's fine. See, on an average, you are talking about using this technology in some way or other. But how good you are using the technology for the professional growth is very important. So my dear students, the technology that is being introduced for our convenience, right? just make a note of this, the technology which is being introduced for our convenience is causing inconvenience for our life nowadays. Right? Every day you are spending 2 to 3 hours on your mobile phone, but not spending some 10 minutes or 20 minutes. You know, those who are in your home, you are not spending time to them to talk to them personally. Right? Your father or your mother or your brother or sister. Right? வீட்ல இருந்துகிட்டே பக்கத்து ரூம்ல இருக்கிற அப்பா அம்மாவுக்கு மொபைல் ஃபோன்ல கால் பண்றாங்க. We want this, we want that. Right? We don't, connect with them, personally. That is what, the people are talking about in the technology. We don't know how the things will be, how the future will be, but I'm sure that this generation students are using the technologies in some way or other. Now it is a time for you to watch. Okay, you are spending some 2 hours on watching the YouTube, fine. You spend some 30 minutes on learning some of the videos of how to use the Python for building some of the mathematics applications. You have a very great future, particularly in the core mathematics and the data analytics or data scientist area. The data scientists and data analytics are the top or highly paid jobs. Right? One of our second year computer science student, last year you got an offer, to join in Berkeley for 22.5 lakhs. It is one of the top, highly paid, job for a second year computer science student. And nowadays the companies are targeting the 12th standard students. So whatever degree that we study, it may become obsolete in the future, right? The companies are telling you, give the 12th standard students, we will make them to study some UG or PG, we will take care. Right? So we don't know how the things will be in future. So you are into the technologies, right? Whether you like it or not, you are into the technologies. It's appropriate time for you to think about how best we can use the technology that is available at free of cost, so that you also will be technology enabled. யாராவது ஒருத்தர் உங்ககிட்ட வந்து பைத்தன் தெரியுமா இல்ல ஏஐ மெஷின் லேர்னிங் தெரியுமான்னு கேட்டா you should be able to probably say yes. Now the mathematics student, it is not related to me and all, don't there should not be any excuses in the future. That is what the world is moving, and we have to be really more careful in choosing this. That is the main reason I have accepted the invitation and thought I can share it with the mathematics students, being a technical person in computer science and having little knowledge about mathematics than you, right? And show some of the interesting projects and what is being done using the Python. I'm sure that this kind of lectures will surely ignite you, will get some kind of interest on you, and if some of you are choosing this as your career and do something, right? And I'm sure that you will be able to come up with the flying colors in the future. Thank you very much. Thank you. Sorry.
How to make use of that output, whatever it is. Because it is in Golang.
No, sir. You can just simply draw whatever it is. You can just save it as an image. Right? All the things, images or whatever it is, you can copy it and put it in a Word and draw some inferences or comments. Any clarifications that you would like to have, or you're free to ask any questions. Anyway, sorry that I'm not able to talk to you much mathematics. It's only the another part of things that a supplementary sort of thing that what the industry or what the colleges are expecting, or even if you want to become a teacher, mathematics teacher, and if you are teaching a computer science student, you should be able to tell all those things. Mathematics for computer science, mathematics for business, and plenty of things are coming up, right? And whenever somebody is talking about technology, don't feel like you are kept out or you are away from that, or it is meant only for them, right? The technology is for all, right? Use it, but don't spend a lot of time on or don't spend any money for learning these technologies, right? நான் வீட்டில் போயிட்டு நான் பைத்தன் படிக்கணும், காலேஜில் சொல்லிட்டாங்க ஒரு 10,000 20,000 கொடுங்க அப்படிலாம் கேட்கக்கூடாது. No, it is available at free of cost, including the software and tutorials I have left. And all the things, when you go to the internet, you will find plenty of videos or plenty of even solved exercises, right? So develop this kind of Python exercises and participate in the competitions organized by the other colleges with the help of your teacher. Okay? Thank you very much. Thank you.
Thank you, sir, for your clear and excellent explanation. Really, this session is very useful and interesting, sir. I hope all the participants would have gained in-depth knowledge in mathematics using Python. Once again, I thank you all for your active participation. And students, please assemble in Dwaraka auditorium immediately.
Stream start பண்ணிடலாம். Stream stop பண்ணிடலாம்.
ஸ்டூடெண்ட்ஸ் எங்கேயும் போகக்கூட நேரம் ஆடிட்டோரியம் போங்க. ஹாஃப் அன் ஹவரில் முடிச்சிடும்.
வாடா சரியா
இதுக்கு ஒரு வாட்டி கேட்டுங்க சார், திரும்ப சார்.
இங்கே வராது
தெரியாது, ஆனால் கேட்டுக்கோங்க.
ஓகே.